Hello everyone and welcome. In this session, we will learn how to convert AutoCAD lines to Revit model pipes. This will be the first step toward converting this 2D plan into 3D firefighting network in Revit using Dynamo. The walls are combined in a block. This is essential to separate them from the network. Pipes are the red lines, while the upright sprinklers are the circles. You can convert any AutoCAD network after cleaning the plan and ensuring that the network elements are connected in the 2D plan. Before starting, you need to import the 2D plan into Revit. Open the Level 2 floor plan from this sample project. Then from the Insert tab, add the AutoCAD file. Make sure the scale is correct. If the imported file does not appear in Revit, you may need to adjust your view settings. After that, unpin the floor plan and explode it to appear as it was in AutoCAD. Every model element shall be represented by single imported element. Lines for the pipes and the detail items for the sprinklers. Delete the additional elements, in this case the bounding lines for the detailed elements. This is important to avoid errors when creating Dynamo scripts. I highly recommend you to save your work before starting Dynamo, because if Dynamo crashes, Revit will also crash. Now delete the unnecessary items before launching Dynamo. The model is now ready. Save it and launch Dynamo. We need to download 2 custom packages for this script. MEP over package. And the Spring Nodes package. In the MEP over package, you can find this custom node that converts model lines into pipes. We need 5 inputs to convert the model lines as shown. Start by selecting the lines from the imported CAD file. You might select them along with other elements, then use Dynamo to filter your selection. This is possible using another custom node from the Springs package that filters the elements based on their categories. Outputs will be classified into 3 groups. Choose the in group to match the chosen category, which is the lines. Now you shall extract the geometry of the lines to use them as inputs for this custom node. Note that the geometry output information for each line is in a separate sublist. This will create an issue for the custom node inputs, as the main list items are logically considered empty. The solution is to move the contents of the sublists to the main list level. Use the List Flatten node to do this. Now the geometry information are at the same level. The pipe type and the pipe system could be extracted using the same method. Use Element Types node, then search for the category. Then extract all the types using this node. In this Revit model, we have only one type for pipes. From the project browser, you can edit or add new types if you wish. I will duplicate this type and rename it. Carbon steel is a good choice for fire pipes. Back to Dynamo, a new type were added. Use another node to find the name of the extracted types, as appear in Dynamo. The fire pipes type holds 1 as index. Therefore, to pick this type, add this node, then choose 1 as index number. For system types, copy and paste the pipe type nodes. Then search for piping system type. And choose the fire protection wet system, holding 5, as its index. Add the level node to choose the pipe's reference level. Remember that Dynamo is running at the automatic mode. Make sure to change it to the manual mode before completing the script. And save your work as well. For pipes diameter, add number node, then choose 25 mm as nominal size value, or 1 inch if your project in the imperial units. After saving your work, run the script on the manual mode. Back to Revit. The pipes were added successfully using Dynamo. Change the view settings if the pipes are not visible. You can use this method in similar applications, like converting the AutoCAD imported lines to ducts, electrical conduits, or cable trays. Consider this as an exercise for you. Convert the AutoCAD imported lines to one of the previous mentioned elements in Revit using Dynamo. Then make a user-friendly interface using Dynamo Player. Now I will change the level of pipes to 2,700 mm above the reference level 2. But for the main pipes in the network, the level will be below than that. This is to comply with NFPA standards. 2,500 mm will be good. Now you can save the project. I grouped the nodes to be more organized and easy to understand. In addition to using orange for input nodes, and adding a small note for the used custom node packages. Each group has a title that indicates its function. I recommend you to use this strategy to avoid confusion when editing or debugging later. The exercise files will be attached as usual. This is the end. Thank you.